Okay. I'm going to use a different word here, isolating a variable, for what we're about to do. It's really solving for a variable. It's nothing different, but before, when we had this, we were going to get a value for x. We're going to find out that if we subtract 3 from both sides, we found out the actual value of 5. But there are times where we get an equation that's all variables, and we actually want it to tell us what is x. So then we might just move around variables only and solve for x. Well, I'm going to call this isolating a variable, getting it by itself. Solving for a variable, it's really the same thing you're doing. It's just getting the idea that you want x all by itself sitting there, with the other variables moved to the other side. So I came up with this little problem here. Let's say there was a company that made these like metal barrels. And they made them in different sizes, any size you needed. And they just always made it so that if this was the radius, 3 times the radius would be the height. So people might order it with different volume requirements. Maybe they custom order something and it's like 16,250 cubic centimeters they want. Sorry. This abbreviation is used sometimes, but in math class I probably ought to. Cubic centimeters. Do it like that. So then if they want this volume, well, what's the radius going to be? You wouldn't really know what to do, right, if we just plug this into here. Right? You don't know how to solve for the R and H here. So really an easier way to get through this problem is to solve it so that I have it to where it tells me what R is. Well, I guess I've been using a capital R. If we manipulated this thing to where R was isolated and everything else was on the other side, I think we'd be in good shape to take our volume that our customer wants and turn it into a radius. Good. So let's do it. So first we're going to substitute in these two things, R and 3R. So that'll look like this. Pi capital R squared times 3R. Okay. So then if I simplify this, that's 3 pi R cubed equals V. So that was just a simplifying step, right? All those days we learned to simplify things with rules 2 through 8. Now to solve for R, again we're going to use rule 9. Divide both sides by 3 pi. And then that's going to be R cubed equals V over 3 pi. So there, we applied rule 9 when we did the same thing to both sides. Okay, now we are going to apply rule 9 again to get rid of this exponent because we really just want to find out what R is. Kind of got too low on the board there. Let me come over here. I'm going to recopy it. R cubed equals V over 3 pi. So cubed means times itself 3 times. Well, is there a way we know how to take the opposite of that? So let's just learn that real quick. Quick lesson on how that works. So 2 cubed equals 8, right? So is there something we can do to 8 that goes backwards? Is there a symbol we have for that? And it's actually cube root. It's asking what times itself 3 times would give you 8. Well, that's 2. Now your calculator can do cube roots, and it'll have a little button that looks, it looks like this. It's just like a square root, but it's a cube root. It asks what times itself 3 times will give you that number. So, for this problem, the way to get this off here is to use that cube root, because cube root is the opposite of cubed. So I'm going to take the cube root of both sides. Again, I am doing the same thing to both sides, rule 9. So that's legit. So the cube root of both sides. So r cubed and then cube rooted, those cross out, leaving us r over here. That's the whole reason we did it. Over here, we're done. There's actually no more simplifying to do. You just have to leave that cube root on there. Nothing else really to do with that. So now, we have an equation solved for r. So now I can take this crazy thing in here and find out what the radius of this guy should be. So let's do it. Oops, let's put the number in there. So what I need to do there is, well, I'm going to let you do this on your calculator since my phone is presently also my video camera. So this is a number you can figure out yourself. And again, it's order of operations. Put it in the calculator. You take 16,250 and then divide it by 3 times pi. You might want to multiply these first to make sure your calculator does the order of operations correctly. If it helps you, you could just divide by 6.28. Oh no, it's 3 pi, not 2 pi. Well, anyway, you can work out what 3 pi is, get a number there, do that division, and then hit the cube root button, and that will give you the radius. But see, now that you have this, if you wanted to find out a different one, like, well, what if somebody wants a smaller one, a 4,000 cubic centimeter gas tank thing, then all you have to do is change this number and do it again. And you've already got an equation, any volume you want to plug in for this guy, and you've got the radius you need to build it with. So there's one problem. I'm going to give you a real world problem on this. More real world than this one. The story I'm about to tell you is actual. And it involves one Mr. Trevor Ott, who had a job working at an auto glass company. He was a young man, and his ability to do this math problem made his employers so happy that they actually leased a car for him for an entire year. He was leased a car because he applied algebra in the workplace where nobody else that was working there could do that. They had all learned algebra, but none of them could apply it apparently. So we're going to look at the problem that he had. So here's how it would go. You would call in with your car. I'm going to take a very ordinary car. Let's take a Honda Accord. So you call in and you say, I've got a 2012 Honda Accord, big rock, jumped up off the road, cracked my window, I need it replaced. It's a common thing, and there are businesses in big cities that just do auto glass for things just like this. So you call them up, and they say, well, that'll be $349 plus tax. This is in the state of Washington, where they have sales tax. All right, here in Oregon, we don't. You're watching this remotely. So, $349 plus tax. Now, sometimes people would call in and say, okay, I've got a 2012 Honda Accord. How much is the window going to be? And they say, it's going to be $349 plus tax. And the customer says, well, really? Because I just called Bill's Auto Glass, and they said it was going to be $325 plus tax. Well, then what they were supposed to say at that time was, I tell you what, we'll do it $325 tax included. And the person would usually say, oh, well, great, fine, I'll do that. Sign me up, and bring the car in. So now the worker has promised this person $3.25 tax included. And the way that they had to come up with a price for this is a little tricky. So they had 9.6% sales tax. And they had a $55 labor cost that there was some union rule, or there was some reason they couldn't adjust the labor cost. They could only adjust how much they were selling the piece of glass for. So there's the problem. You've got to come up with a total of exactly, you've got to come up with a problem of a total of exactly $3.25. You start with some cost of the glass. We're going to call that X. I think actually, no, you start with the $55, either way. You add the cost of the glass. You get a subtotal. And then you have to add sales tax to that. So you got to multiply it by 0.96. Like that. And then well, actually, I don't have a way to make this. This is going to get too crazy. You got to multiply it by 1.096. Let me just show you that. If I was going to give you 10% sales tax, 10% looks like this, right? So if I had $5 and I multiplied it by 0.10, well, that's going to tell me how much tax, 50 cents, right? But if I multiply it by 1.10, then that's going to give me $5.50, which is the total of the cost plus the tax. The 1 times 5 gives you the $5 that you have to pay for it, and then this gives you the tax you have to pay on top of it. So it really simplifies our math and the way to express it, just to say this. So there's the labor cost, 55. There's the parts cost, which is adjustable. That's going to give us a subtotal. Then we're going to multiply that by 1.096, which is going to boost it up 9.6% to some total, and that has to arrive at 325. So here's how they would actually do this in this business. This is actually how they were doing it. Let me just make sure my camera's still coming here. Still going. The guy, the salesman, get off the phone. He goes, okay, I promised him 325. Pulls out his plain old calculator back then. And he would take a guess at this number. Like he would go like, well, I don't know, 260? So he would try it out with 260. He would add that together. So 260 plus 55. Okay. That's confusing. So he adds those numbers, gets a subtotal, types in the times, 1.096, he gets a price. He might find out that his guess put him at 321.36. So then he knows he needs to raise this number a little bit. So he picks another one. So it would take him about 6 guesses to get them to where it goes bam, 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 and the calculator spits out exactly the price they quoted over the phone. So that was spending a lot of time in the salesman, and the salesman should really be on the next call helping the next customer. But the customers were sometimes having to wait, and that sort of thing. And so as Trevor was working there, he was like, wait a minute. Doesn't algebra have a way for us to do this? And so yes, there is. So let me write out what I had here more in algebra, more in an algebra form. So 325 tax included, that's what we're shooting for. So what Trevor did there was basically solve for the variable that he wanted. So here's how it worked. We're going to call the thing, the cost of it, the part is P, plus the labor, that total, times 1.096 equals quote, like, I guess I should just say total, the total. equals the total. The total that we had quoted them. You know, when you tell them the price you're willing to accept, that's giving them a quote. So this is their total. Parts plus the labor times that gives a total. And the labor was the fixed amount. So rather than leave a variable in there, let's go ahead and put 55. That was always the same. Now, what we want to do is have the parts cost isolated. Because that's what this guy was doing with his calculator. How much do I charge for that part? He was guessing and guessing and guessing at numbers that would go in here and make this work out to 325. So we're going to take this one right here that has the two variables, the total that he quoted over the phone, and the part of the cost of the part, and we're going to rearrange it so it just tells us P and then a calculation to do over here. And once we do that calculation, we only have to do that once, and that will tell us what we need, rather than the 6 guesses that were happening with arithmetic. What we were doing here over and over here was arithmetic. But so here we go with the algebra. So we got to get P by itself. So both sides are times 1.096. So we're going to divide this by 1.096. Okay, so those cross out. Then that leaves us with P plus 55 equals the total over 1.096. Okay, then we're going to subtract this from both sides. Obviously those cross out, and that's the completed expression. So, there you have it. That little thing right there, you type in 325 right here, you go 325, divide it by this, subtract 55, bam, you've got the parts cost, and that salesman can write that number down and get on to the next phone call. That saved the company so much money, or helped them increase their profits so much, that the owners decided to lease a car for Trevor for the entire year. Well, he's just a guy who actually could apply algebra to something in life. And nobody else that he was working with, many of whom I'm sure took some algebra before that, figured that out. So that's definitely a real world one.